Uh, Good afternoon, guys. Thank you for coming here today. And my name is Mai, and I'm a member of our group. The topic we focus for today is automatic park lighting. It include crowd detection and automatic lighting. We have three members: me, Mr. Tan So-win, and Ms. Joanna Sophia. Uh, We our presentation have five parts. The first is the introduction. The second is system overview. The next is the crowd detection. Next is lighting system, and the final is automatic path lighting demo. I'll go to introduction. We talk about the user story and acceptance criteria. We have two user story. The first is out of power stuff. I want to automate the power lighting system to optimize energy consumption based on daylight condition. And we have four acceptance criteria. The first is I want the system to automatically adjust the brightness of park lights or control their on or off status based on readings from special light sensor that measure the current ambient light condition. The second is I want the system to accumulate and store historical data regarding light level and operational functionality. The next is I want to optimize this information for park management to study system usage, identify, improve opportunity, and establish more efficient lighting schedule. And the last one is I want to be notified at the moment an issue arises in the lighting system, minimizing downtime and ensuring fast resolution. The next user story is at a park stop. I want to monitor crowded situation so that I can identify popular spot. The first is I want to monitor crowded identified in real time. The next is I want to identify popular area within the park during specific time. It uses information to suggest optimal location and timing for the event activity. The last one is I want to modify the lighting intensity during the nighttime when there is an increased power density with the primary goal of ensuring safety. Go to the next part is the system overview. We compiled the different devices to develop an integrated system that combines smart lighting and power management functionality. In the part, the system optimizes the camera and light, relates the sensor to objective. About the system overview, we using the ESP S32S3 camera. After the camera capture image to detect router using model, and we send the model result to MQTT, and the lights based on the natural light data from the LED light also sent to MQTT, and the message or data from the MQTT will be collected and uploaded to database. Besides, in order to show the data collected real time in the database, we using the stream list dashboard to display the data. We use logic to access or retrieve the data from the database to show on database. The next is sequence diagram, and we have the two user story. The first is automatic lighting system, and park stop. We make a request to the optimize energy consumer and the system. And the system will be sent a measure ambient light parameter, and The light-based automation and learn light level. The system is higher turn on or turn off the light. If the light level high, sorry. if the if the light if the if the light level high is will turn off and the light level low is adjust when it or turn on the light. The lighting system will set the store historical data to database and send the notification is clear user. And the next is the user story tool is monitor product situation. The first step will send a request to monitor product situation to the lighting system and monitor product that stay in real time. Go to database and identify popular spot within the path. Go to database. And the next part is the crowd detection with ASP32S3.
Right, so I'd like to talk about the part I was responsible for, which is the crowd detection with ESP32S3. Obviously, in order to detect the crowd, we need to have an AI model. So in this development process, we needed 5 stages in order to complete it. Let's take a look at the stage 1, first stage. So here we had to collect images which were from in different conditions. Actually, 2 main conditions, bright condition and also dim dark conditions, in order to create a proper data set. And the data set consisted of 126 images. After that, we needed to label our images to know where the person is, and so we could train the model correctly. And after that, we then designed our impulse, which included setting the data settings, the image, the size, also the parameters and the features that need to be generated from our image. And we then also had to configure the settings for our neural network, which we used the FOMO model. And the performance was pretty good at about 91%. And then in our 4th stage, we tested our model. So the way we did this was we took a picture using the SP33, then uploaded the model onto the picture onto the model, and it was able to detect, as you can see, the centroid at about 74 to 98%. And then in our last phase, we then deployed our model using the Arduino library, and we had to build it onto our ESP33 board and then upload it. And as you can see in the serial monitor, once we started running the model, it was able to detect the number of people in a frame. And actually, this captured every 2 seconds. So it is showing the data here, and it's also sending the message onto the MQTT broker so we could use to store in our database. Next up will be the demonstration, in which consists of the camera working together with the MQTT and uploading onto the database. So as you can see here, the camera is running, is uploading to the MQTT, sending the message, and you can see the graph showing on MQTT the number of people that it can detect in every 2 seconds that it receives the message. And on our database, you can also see the most recent uploaded image. This was done Sunday, so we can see the data that is uploaded. Even if it doesn't detect a person, it also tells. If it detects, then it also uploads it onto the database. And in the next demonstration, it's going to be combined with our Streamlit user interface. I created the sign in and login page, which use the Firebase authentication. If you're a new user, you have to fill in the necessary information onto the web. And then we then can see, if you could see a while ago and a bit, sorry, I'm gonna try and see if we could, yeah. So if we're not logged in into the system, we cannot see a dashboard because dashboard is only for the staff. So once the staff signs in using their email and password, then you can see that the information they used during signing up is shown. And one feature that we actually wanted to add onto our project was chatting through the dashboard on our Streamlit, but it wasn't able to materialize. But the general idea is if the staff sees that there's a light that's not working, or maybe the camera needs some checking, or maybe there's an event at the park, say there's firework tonight, and the setting of the light needs to be adjusted to much more lower brightness, then they can send it onto the dashboard, and the staff can then reply back saying sure. And then next up is the dashboard, in which we can see the data. The camera's working behind the scenes, and it is getting data from the database real time. So it's showing the current number of visitors that you can see in the park, and also there's a graph that the staff can use to utilize to analyze the trend, the number of people in a particular zone, so they can see at which time the park is popular. And also they can try to make necessary adjustments to your system if need be. For the light part, I'd like to let someone do the presentation.
Okay, for the live, we have live development, system development. For the live part, we will use for ESP32S3 box for the camera to detect the person. And then I have used the ESP32 dev module for the light sensor. And I have used the earlier light sensor and the LED light. So from the ESP32S3 box camera detect the person, I have subscribed the topic with the camera, so that if the person is detected, my light should be start working. Once the camera detect person, so the light sensor will detect the environment light that is the brightness level. If the brightness level is low, so my light system start working. In between, I'm using the MQTT broker. I use the Mosquito MQTT broker as a broker. So from the ESP32S3 box send the topics that the person is detected, so the light sensor should be working. After that, the light sensor will detect the brightness levels of the environment. And then based on the brightness level, the LED light will be turned on. So from the sensor data, we send to the Express server using the broker. Then the data will save in the MongoDB database. Our lighting system, we have add one more function which call for the emergency light. If something is the system is not working well or something, so that the staff can control from the system that turn on the light or turn off the light. So for our system is we have two functions, crowd detections and automated lightings. This is the demo video.
Okay, the camera is not detecting a person, so the visitor count is 0, and the light on with the minimum brightness. Okay. Now the camera detects person, so the visitor count will be going up. Total count will be go up also. On the graph also the count will be up. And then the light, based on the brightness level, the light will adjust. And so if the outside brightness is become higher, so the light the light power is become lesser. So yeah.
So when the light, the consumption of the light energy should be higher, the power is higher.
when the brightness levels is become the highest, so the light is totally turned off. That means that daytime the light will be totally turned off, even though the cameras detect person. Okay, this is the light and camera parts. Okay, for the dashboard back, we have saved all the data day by day. All our data is saved in MongoDB. So this one is the light data for each zone. We have 2 zones. So for zone A, we can see all the data from the database. Yeah. This is the total usage for this day. This is the total usage for the yesterday. So all the data we save here. So the saving data is real time. So you can refresh. So we can see different energy usage. So we can export all the data here, which type of data you want, JSON or CSV. We can easily export it. Okay, here zone is we save all the visitor count. So the visitor count all here. So today and yesterday, or we can see here. The data also save real time. So if we refresh, we can see the total count is increased. So we can compare from here, but the update is a bit slower than our front end dashboard. Okay, then the other function is emergency light. So if in case that the light is in something has happened, we have the emergency light function. So if we can on off from our control center or somewhere. So this is emergency light. We on, off, on, off. This is our emergency light. This is the graph showing that our total visitor count, so that we can easily check from the dashboard as well. Okay.
This one is we did demo with only one zone. Now we have another one is we did 2 zones. So we can see all the data flow as well from the VS Code. So if the person detected, then the light should be working. So I have set 2 camera left and right. So 2 zones working together. So the light will turn off. So the brightness is high. This is another zone. Okay, thank you so much. Any question?